Alright, this is Mr. Gillum, and today we're going to be looking at reflecting points. This is our instruction book at page 132. So that Sophia draws three triangles. What is the relationship between the coordinates of the vertices of triangle ABC and triangle DEF? What is the relationship between the coordinates of the vertices of triangle ABC and triangle GHI? So we have two questions to consider, and we have a word in there that we haven't really talked about. So we need to know what the relationship between the coordinates of the vertices of a triangle ABC and DEF, and then also ABC and GHI. And so the first thing we need to talk about is what the word vertices means. Okay, the points. Those are the points or tips of the triangle. Of course, if we said the tips of the triangle, it doesn't sound very mathematical, so we call each of those a vertex. All of them together are called vertices. This is plural, or more than one, of vertex. Okay, so each of the points on a triangle is called a vertex. Altogether, they are the vertices. All right, so what we need to do is we need to look at ABC, which is in quadrant 1. That's the triangle. We're going to compare it to triangle GHI. No, DEF first. DEF. And also GHI. So now let's take a look at some of these additional questions that they have. It says that you can list the coordinates of the vertices of each triangle to understand the problem. So what they've done is they looked at the coordinates for each of these letters and they've identified what the coordinates are. So A is at the coordinate 1, 2, and then 7. 7 in the positive. So positive 2, positive 7. A is the coordinate 2, 7. And they've done this with each point for each triangle. So they've done A, B, 2, 3. So 2 to the right, 3 up. That would be positive 2, positive 3. C, 8 to the right, 3 to the north or up. So we would call that positive 8, positive 3. Coordinate D is way down here. So we are still going to the right in the positive direction 2 and down 7. So 2, negative 7. We have E at 2, negative 3. We have F at 8, negative 3. That's the second triangle. And then finally we have triangle GHI. G is at negative 2, 7. So back 2, up 7. H negative 2, 3. So back 2, up 3. And I negative 8, 3. Okay, and so we just labeled where each of these coordinates is, what its actual coordinate position is. It's going to be important because we're going to start seeing some similarities here in these triangles. So if you notice on A, 2, 7, D, 2, negative 7, G, negative 2, 7, although they are different positive or negative values, they are still using the distances of 2 and 7, the absolute values of 2 and 7, the distances from the origin are 2 and 7. Same with B, E, and H, 2, 3, 2, negative 3, and negative 2, 3. Although they're not the same positive and negative values, they are the same distance from where we're starting, the origin. Okay, the absolute values are. Same way with C, 8, 3, 8, negative 3, or negative 8, 3. And so when we look at that, we may not have been able to compare very well before we wrote the coordinates down, but now that I see that the coordinates are all different opposite numbers, that's going to help us describe what's happening with the two triangles and when we compare them and the relationships between the triangles. So it says, across which axis do you reflect triangle ABC to get triangle DEF? Now, when you think about reflection, think about when you look in the mirror, you see the same exact thing but on the other side. Or if you take your paper and you fold it in half and you unfolded it again, if you had like I don't know, water on one side, then it would be on the other side and exactly the same distance from wherever you folded it. So when we look at triangle ABC and we compare it to triangle DEF, if I folded this coordinate plane somehow, I would have to fold it on this axis for this triangle to end up right on top of this triangle. We call that a reflection. Okay, so it's like this triangle, looked in the mirror, saw this triangle. The closer you get to the mirror, the closer your image gets to the mirror. The farther you get from the mirror, the farther your image gets from the mirror. And so if I folded this coordinate plane along this x-axis, I would have ABC right on top of triangle DEC, or DEF. So the axis that I'm reflecting over is the x-axis. The horizontal axis is the x-axis. This is the x-axis. So let's look at the coordinates of A and D on the graph. What is the same and what is different? Well, A is this guy right here. Okay, and this guy is at 2, 7. D is this guy down here, and he's at 2, -7. So are there some things that are similar, and there are some things that are different? Similar things would be the x-coordinate, the value to the right. Things that are different would be the y value, 7 up or 7 down. So the y values are opposites, we could say. We could also say that they are similar in that they are the same distance from the x-axis on the y value, but they're just on opposite sides. So both x-coordinates are 2. The y-coordinates have opposite signs. They are also the same distance from the x-axis, just in a different direction. So let's compare the coordinates of point B and E and point C and F. How do the coordinates of a point change when it is reflected across the x-axis? So point B, let's just write these down. So we're going to compare point B. That was at 2, 3. And we're going to compare that with E. E is at 2, -3. And then we're going to also compare points C and F. Point C is at 8, 3. And point F is at 8, -3. So just like point A and point D, I'm noticing some similarities. They're still the same distance from the x-axis, but the y values are actually opposites. 3 and -3 are opposites. 3 and -3 are opposites. And they're actually on the opposite side of the x-axis from one another. So when it says, how do the coordinates of a point change when it's reflected across the x-axis? If we're reflecting across the x-axis, what is changing is the y values. Okay, so that's counterintuitive. You'd think maybe, oh, the x values would change because it's the x-axis. No, that's not quite how it works. The y values are actually changing to the opposites. The x-coordinates stay the same. The y-coordinates have the opposite sign. Okay, so you can see, and that's something you can figure out just by listing the coordinates and looking at their values. It says, across which axis do you reflect triangle ABC to get GHI? So now I'm looking at ABC again, and instead of looking below the x-axis, I'm looking across the y-axis to get to GHI. So I'm reflecting, if I folded this coordinate plane exactly in half, I would have ABC laying right on top of GHI. So we're actually reflecting across the y-axis in this case. Comparing the points of G and A. So point G would be -2, +7. And point A we know is 2, 7. And then we're also going to compare B and H. B and H. B is 2, 3. And H is -2, 3. It says comparing those, oh, and C and I, sorry about that, C and I. So C is at 8, 3. And I is at -8, 3. It says, when we compare those, how do the coordinates of a point change when it's reflected across the y-axis? So when we looked at the last example, we were reflecting across the x-axis, and the y-coordinates were opposites. If you look at these, you can see that all the y-coordinates are the same on the points that we're comparing. However, the x-coordinates in this case are opposites, from 8 to -8, 2 to -2, -2 to 2. So those are opposites this time. So when you reflect across the y-axis, it's actually your x-coordinates that are being changed. They are the opposites. The y-coordinates are staying the same. So reflecting across y, y stays the same. Reflecting across x, x stays the same. Whatever is staying the same, the other coordinate must change, must be the opposite. So Brandon draws a reflection of the point -4, -6. He gets the point -4, 6. Across which axis did he reflect the point? Explain how you know. Okay, now we could draw a picture for this, and I will in just a second. But when I just compare the two coordinates, -4, -6, and -4, 6, I noticed that the x-coordinate did not change. It's exactly the same. And what that means is that's the axis that it's reflecting across. The y-coordinate did change. These are opposites. So when I think about that, I think, okay, well, one was going down and one was going up, so it must be reflecting across the x-axis. So I'm guessing in this explanation it's going to say something about, well, I know that it reflects across the x-axis because the y-coordinates are opposites. But also, if you weren't convinced about that, and I know you were still learning about this and still visualizing in your head, we could actually draw or sketch the two coordinates. So there's x and there's y. Positive and negative. Oh, positive, negative, negative. -4, -6 would be back 4 and down 6. So down here somewhere. And then 4, 6 would be back 4 and up 6. Right there somewhere. So you can see that if I folded it along the x-axis, that's where those points would line up. So that's the axis that they're reflecting across. It says that Flora reflects the point 5, -10 across the y-axis. What are the coordinates of the reflected point? Explain how you know. Okay, well, -10 across the y-axis. Then my new point should have the same y-coordinate. Reflecting across y, I'll have the same y-coordinate. So I know that will be the same, but my x-coordinate will actually be the opposite. So I know that the new coordinate would be -5, -10. I know this because when we reflect across the y-axis, the y value stays the same and the x value is the opposite value. So -5, -10, x-coordinates have the opposite signs, y-coordinates stay the same. If we weren't convinced, we could always sketch on the coordinate plane. Here's 5, -10. We're going to call that 5, 10, somewhere down here. It's opposite if we're reflecting across the y-axis. Then it would be the same distance on this side. It would be in the third quadrant. Okay, so if I'm going to the left, I'll have to go this way instead of to the right. That means my x-coordinate will be the opposite. My y-coordinate will not change at all. Okay, so you can always visualize it if you prefer. That's it for today. We're talking about reflecting points. If you're reflecting across the x-axis, the x value does not change. If you're reflecting across the y-axis, the y value does not change. So hopefully that will help you keep those straight. But that's it for today.